Hi everybody. I've got quite a few pieces of test equipment in the workshop. Some of it's purchased and some of it's homemade, and some of it are a bit of a hybrid of both. And today I've decided to modify a Maas 50 amp power supply that I've got, and convert the analog meters on the front of it to digital. Let's have a look. Okay, here's the power supply. It's a pretty cheap 12 volt 50 amp power supply. Well, it's variable from about 8 to 15 volts. And I've already modified it a little bit here. The actual 50 amp terminals are, they're on the back usually, but that's no use when it's up on the workbench on the test shelf up there. So I already moved them to the top of the case here, and in doing so got rid of the cigarette lighter socket there. Didn't really use it, so that's as it sits. But I've never really been a fan of analog meters. When you've all your other test gear on the workbench is you've really got digital readouts. So I thought I'd see if I could convert these to digital. And what I managed to get a hold of is these cheap LED voltmeters on eBay. Pretty fast from China. They run off of 7.5 to 15 volts, I think it is, and about a 75 millivolt input signal for 0 to 99.9. So I thought if I could possibly maybe mount a couple of them for the voltage and current meters here. So here's the actual rear of the panel meters themselves. They're actually one big meter with the two actual movements inside it. And then on the back here you've got a PCB which interfaces the signals to the meters themselves, and also the power to the backlight for the meters. And I've done some digging around, and I can see that the actual input signals here for the current drive and the voltage drive come off at this side here, and they're already down at a millivolt signal level. So I'll trace it back to the circuit board and see what we've got, and see what I need to interface the digital voltmeters that I've got. Obviously the meters themselves are not going to, it's not a direct replacement in any way, shape or form, so I'll probably cut out an aluminium plate here that'll fit this gap here, spray it black with a couple of holes in it, and so that the meters fit nice and clean, and it'll look quite good at the front. But I think before I do all that, I think what I need to do is actually test, just hook up the meters in place of the analog ones without doing any physical damage or destruct to the power supply itself, and let's see what sort of stability I get on these digital readouts. It's always a concern when you're replacing analog meters with digital panel meters like this, that you're going to see every millivolt, if not microvolt change on the signal to the meter if it's a digital readout, but you won't see that on an analog. So it really depends on how stable the drive is to the original analog meters, and if necessary, add a little bit of filtering on there. But I just thought it'd be a fun thing to do and give it a whirl. So I'll let's hook up one of the analog the digital meters and see what happens. And oh yes, and by the way, these digital panel meters are 4-wire devices. You've got the power on the red and black, and then the input signal on the green and the blue. And these particular meters themselves are the power has to be isolated from the input signal, i.e. you can't common up the negative input signal and the power supply negative just to give it a single-ended input signal. It won't work. They have to be isolated. So what I'm going to do is I've found a couple of DC to DC converters that I'm going to put in line with the power to the actual panel meters themselves, and then that'll allow me to common up the commons. What I've done is I've hooked up my DC-DC converter on the back of the voltmeter. It's a 5 volt input, 12 volt output, so it's fine. The 12 volt drives the display okay, and the 5 volt rail, just by luck, right down in here in the power supply, there's a 5 volt DC regulator which powers, I presume, this interface board here, little control board there, and it shares the same common as the meter drive. So perfect. Got 5 volt interface for the displays themselves, and the actual voltmeter here is driven, I think at about 10 volts it's driven by about a 245 millivolt signal. So what I've done is, just temporarily to get things up and running, I've hooked up a wee trim pot here so that I can get to that voltage down to, you know, roughly 50-60 millivolts on the display itself or so that I can get things going. So let's power up and see what happens. Okay, I've hooked up the fluke to the output from the power supply, so that I can adjust the trim pot and see what if we can get the display to match, and then I'll vary the actual output of the power supply itself and see if it follows. So let's power it up. So we're reading just over 10 volts on the fluke, and the readout on the voltmeter's a little bit high, so let's screw it down. At the moment I've just got the trim pot, I've got no filtering, nothing, so if there's any noise in the system I want to see it before I start. Okay, so there we have 10 volts. Actually it's quite stable. Luckily these small voltmeters, there's only 1 decimal point, so it should be quite stable anyway. Okay, so let's vary the output from the power supply and see if the voltmeter follows. So let's screw it right down to start with. That's 7.92 on the fluke, and yeah, about 7.9 near enough on the voltmeter. And right up. 1504 and 15. This is looking good. Unfortunately this power supply only varies between 8 and 15 volts, so it would have been good if it had gone down to maybe, you know, less than 1 volt, something like that, but you know, it really is just a 12 volt power supply really, with a, you know, a bit of a vary somewhere around that. But yeah, I'm quite happy with that. It's stable enough. Yeah, it's looking good just in there. And if you can't really tell on the LCD in the camera, but these voltmeters really is a bright red. It looks kind of, I don't know, just washed out on the video, on the camera anyway, but they really are a bright display. Really good. Yeah, so I think the next thing to do is play around with the ammeter. Okay, I've now got the ammeter hooked up. I had to do a little bit of a tweak because the analog ammeter has a residual 16 millivolt drive to it, which you wouldn't necessarily see on the analog meter itself, but you would definitely see it on the actual digital meter here. So I've had to bias the inputs to the DVM here, the voltmeter, the digital voltmeter here, with an offset of about 16 millivolts as well, in order to compensate. So now I've got hooked up now to my dummy load, and it's 0, and power supply's output 10 volts. So if I switch on the dummy load and dial up 2 amps, so I'm running at 10 volts, 2 amps. There we go, I've got 2 amps on the display, and I can wind it up here and go up to 5 amps there, so it's 10 volts, 5 amps. it's tracking quite nicely. I'll see, I'll go up a bit further. Oh, there's 8 amps, 10 volts, and it's tracking very nicely indeed. And it's actually quite stable, no jumping around, no jitter, so I'm actually quite happy with that. So I think what the next thing to do is to obviously tidy it up a bit, pull out the analog meters, make the aluminium bezel, and mount them on the power supply. Okay, that's the analog meters removed, the PCB in the back as well, so that's going. And I've made the aluminium bezel for the 2 meters, and that's the back of them. So I'll just do a test fit here and see what happens. I think that looks good. I haven't bothered to paint it black. I'll just I think I'll just leave it silver. But there we go. So I'll some hot glue to keep it in place, and then we'll wire it up. Okay, that's the panel meters installed into the power supply, and it's all hooked up, and it's more or less calibrated. So I've got the voltage output set to 10 volts, and I've got 4.2 amps on the dummy load, and it's showing 4.2 in the display. So I'll turn up the load. There we go. It's all working good. Down to 0. There we go. And back up again, so it's working good. Back to, I'm sitting at 2 amps now, and I'll adjust the voltage output is adjustable on the front of the power supply. And like I said, it's 8 to 15 volts. So I might try, see if I can modify the power supply at all, and see if I can get to, I'm not too worried about the top end, but I wouldn't mind getting the 8 volts down to 5 volts or something like that would be good. But 15 volts is okay for the top end, but I think it looks pretty good. I much prefer the digital meters compared to the analog ones. And there's a rear view of the panel meters themselves. You can see them, the DC to DC converters I've used to isolate the ground on the panel meter supply and the signal negative. Like I said, they can't be paralleled up on these meters, they've got to be isolated, so DC to DC converter does that. And it's their 5 volt to 12 volt DC to DC converters. There's a nice 5 volt supply available in the power supply anyway, so that was good. Okay, there's the power supply installed up on the workbench again, all ready for some Segway action. Driving motors on my homemade Segway.